Hi, I'm Jesse Miner. I'm a PhD candidate in the School of Geography at the University of Arizona. I'm a physical geographer, and I come with a background from geology and fishery science as well. I've used a lot of field methods over the course of time, and so what we're going to talk about here is pacing, compass work, which can be done in a few different ways. What we're going to talk about today is pacing and how to use a compass for a variety of field measurements. Pacing and knowing your stride length is a pretty useful way of covering distance and calculating distance without having to strictly measure straight lines, which can often be pretty difficult in the field. And so pacing has the advantage of being pretty time efficient and accurate if you do it properly. Pacing may seem a little bit arbitrary and unscientific, but if you're consistent about how you take your paces, and if you know your stride length, you'll find that it's actually a pretty reliable method of measuring distance in the field. It's a common method in forestry, range science, and a suite of other environmental sciences. Because your stride length, your pace, differs person to person, you're going to need to actually go out and measure against a fixed distance your stride, your pace, and then you'll learn, every pace distance, basically on average, that you have. And we'll get to that later in the lab. When it comes to compass use, you can do a lot of different things with them. So in geology, we'll often measure the linear features and then also where they dip into the surface, so strike and dip. And you'll use the compasses in different ways to figure out such a thing. And in a lot of other environmental field methods, we'll use compasses for one thing, orienteering, so getting from place to place, so finding distance and direction. Also for taking important environmental measurements such as aspect, or the direction that a slope faces, which has a lot to do with how much sunlight it receives, other ecological factors like soil moisture. And then also we can use it for taking slope measurements and measuring the height of objects. Compasses look complicated, and they have a lot of things on them, but it all comes down basically to a couple simple functionalities. So you have a north arrow that's always pointing towards magnetic north, and you have a series of grids and dials that help you either transfer things onto maps or to use it in the field for things like distance and direction. One of the important things to know about a compass is that the magnetic north end of the compass is always pointing to a particular point on their surface, which is magnetic north pole. And the magnetic north pole and the true north or geometric north pole are not in the same place. On top of that, the magnetic north pole moves over time. And as you can see on this map, over time it's been sort of wiggling its way through the Canadian archipelago and up into the Arctic Ocean. And so that tendency of the magnetic north pole to move over time means that you need to know where it is now. And also, you need to account for the fact that these poles are actually located in different places. So we call the difference between the magnetic and geometric north pole declination. And what you have to do is you have to correct your compass for that declination, or else what will happen is you end up being off course. If you were in a place where the angle between magnetic or geometric north and magnetic north is 16 degrees, if you were to walk 1.25 miles at 16 degrees off of true north, by the time you finish that 1.25 miles, you would be off course by an entire third of a mile. And so it's really important to know what your declination is for the place that you're occupying, and then how to correct it on the compass. There are a few easy ways to remember how to correct for declination. The way that I find easiest to remember is the acronym LARS, which means left, add, right, subtract. What that means is, so if you have true north, and if magnetic north is off to the left, while you're facing north, you need to add numbers back in to make it, to actually get your compass to tell you true north. If you have true north and the magnetic north is off to the right, you need to actually subtract numbers to bring the declination back to true north. You can either do this mentally, or you can actually physically change where your compass is pointing in order to correct for declination. We show you how to do that later in the video. This image here actually shows you where those isolines, magnetic isolines, fall on the Earth. The dark line through the center, which goes through the eastern end of Mississippi and down through basically New Orleans, is the 0 line. So if you're on that line, it means that you're on a special place on Earth where magnetic north and true north line up. So that magnetic north pole and then the true north are actually in a perfect line, and your compass will point you there. But if you're not on that line, you're going to have some kind of declination. And so if you move east from that line, then that means that the magnetic north pole is to the west of where you're looking at. And so you actually need to add numbers back in to pull it over to be true north. And if you're to the west of that line, magnetic declination is to the east of true north, meaning that you need to subtract numbers. You need to subtract whatever number is appropriate to actually have true north and magnetic north line up. And so if you look at where we are in Tucson, this map would show probably about a 10.5 degree declination difference. But we looked it up earlier today because these things change over time, and this map was made in 2010. The declination for this point in time, for right now, is 10 degrees east of north, meaning that whatever your magnetic compass tells you, you have to subtract 10 degrees from that number in order to get true north. If it helps, there are other ways to remember this. Grid to mag, so grid north to magnetic north. In the image that's featured here with the west declination, you'd have to actually add to get back. Mag to grid, you'd get rid. That's actually, this mnemonic works only if you have a west declination. And it may be that having a second way to think of it helps you out. Okay. Your compass is also equipped with a little swinging arm called a clinometer, which can help you take both slopes and also the height of objects. The long edge of your compass is not particularly long though, so if you can imagine putting that down on a slope, there's small differences in the slope, and so you'll probably get some errors. You can fix that by taking a longer rigid object, like a ski pole or a crutch or whatever you have with you, to lay that down and then put your compass on that longer rigid object, and that'll average out the slope value for you. Later in this video, we show you how to set your compass for taking measurements with the clinometer function, and then we have you measure slopes on a lab. Thank you for listening, and I hope that this tutorial has been helpful. And next, you can watch videos of these tools in action in the field.